All right. So I got 235. I guess this is the first time seeing you since the break, so we had a good break, although we are midweek already. Um, Today is October 30th. Assignment 3 and tutorial 6 are due this weekend, so make sure that you hopefully have started working on them by now. It is just an addendum in some sense to the previous assignment, but again, C++ being what it is, there's lots of tricky potholes if you start late that you can get caught in. So I would recommend getting started earlier rather than later. But your assignment 2 marks, I believe, have been released, right? So again, just if you have any issues, contact your TAs, and then if you can't resolve them, I'm happy to take a look at it. Your midterm marks, I think I'll have to double check the emails, but I think it's like today they're due. And then so maybe tomorrow, and sometimes these things trickle off a day or two late, right? If some of the TAs are busy with midterms or whatever. But yeah, I think that about covers it for now. Any questions on our schedule? All right. So, wow, like 3 weeks ago, we were talking about polymorphism. So we're going to continue talking about that today. The order that things are listed in the calendar is not quite going to be the order that we're going to look at them, but that shouldn't be a problem. Just a quick review, I guess, since it was so long ago. Polymorphism. So we had well, let's be thorough if we're going to do a review. So we had a class hierarchy with animal at the top, and then we had like a bird and a cat and a chicken. And now the idea was that, I defined some general algorithms, or sorry, some general functions in my base class like speak, but I really don't do much with them, right? I say the animal talks or whatever. The idea is that when I inherit these functions in my derived classes, that I do something more specific with them, right? So that my bird will say tweet, and my cat will say meow, and my chicken will say cluck cluck. So that's, one of the ideas behind inheritance is this, but that leads to, and also the fact that we have an is-a relationship when we use public inheritance, right? So a bird is an animal and a cat is an animal, which means that we can do some fancy stuff like this. We can pop them all into a vector of animal pointers, right? So here I can make an animal, I can make a bird, a chicken, a cat, and they can all go in the same vector. Even though they're slightly different classes, they're related enough that I can put them together. And then I can, using polymorphism, I can call the speak function for each of them. And then what happens is that, well, it's not exactly clear at this point. Since it's C++, we have a choice. In this case, we made this a virtual function, which means that, well, actually, before we talk about virtual functions, if we took that virtual keyword away, now speak is not a virtual function, and we have what's called static binding, which means that when I call speak on all of these animals, it's going to go directly to the animal class, and it's going to use this very general, this animal talks or speaks or whatever, right? Which is not really, in some cases, that's the behavior that you want, but I've made all these specialized functions that aren't being used, right? So that is called static binding, where I look at the type of handle, which in this case is an animal pointer, which means if I call speak, I look at the speak function from the animal class. All right, so what we want in this case, and what Java does by default, is we're going to tell the compiler, we actually want dynamic binding. So the dynamic binding means that the compiler or the runtime doesn't know until runtime which of these speak functions is going to get called, right? So it can inspect this code and say that, oh yeah, it's an animal, some kind of animal that's speaking, but there's this whole hierarchy, and each of them has their own individual speak function. And I'm not going to know until runtime which one I'm supposed to be calling, right? So this is known as dynamic binding, and that gives us this power of polymorphism, where I can write this very general algorithm, right? Just a for loop, and I call speak on everything. But then which function gets called depends on the object type that's actually being pointed at. Okay, so that's dynamic binding. That's what happens in Java by default. In C++, we can choose one or the other. For the most part, we're going to be using dynamic binding here. That has the last thing we looked at that has an extra implication is that if I want to use polymorphism, that is, in this case, I'm using animal pointers that are pointing at subclasses or derived classes of animals. And then if I want to call delete on those, well, I should almost certainly have a virtual destructor, right? It is not a good idea to not have a virtual destructor. If I don't have a virtual destructor, then what's going to happen is that I'm going to get the animal destructor called and the rest of them will not get called, which can cause problems, right? I need to clean up some resources in my chicken class. I need to delete an egg. But if the chicken destructor is not called, I don't get to delete that egg, and that's a memory leak. So in almost every case of polymorphism, I probably want these virtual destructors, right? It's just a no-brainer. You should just do it, unless you have a good reason not to. So that's approximately where we left off. Any questions? Okay. So to pick up on that idea, the next thing we were going to look at was abstract classes. Yeah. So abstract class is any class with an abstract function. In C++, an abstract function is also known as a pure virtual function, right? So, and what that means in a practical sense is it's a virtual function, right? We use the virtual keyword and we write the definition of it, but we do not include an implementation. And in fact, we set that function to be equal to 0. Right. So for instance, if I wanted to have a print function, but it didn't make any sense because my abstract class is too general, I don't really know how to print something that is too general, then I would use the virtual keyword and assign it 0, which is sort of like a null. It's like a null pointer, right? So technically speaking, when you define a function, right, this print function is actually a memory address, right? It's a pointer to a function. So now I'm setting that pointer to 0. So when the compiler looks at it, this is sort of like a null pointer on a function, and it understands that this is a virtual function. So this is how we define an abstract function, and if my class has at least one abstract function, then it is an abstract class. And if I have an abstract class, well, there's a few things. One is, of course, I can't instantiate it, right? I cannot make an instance of, well, I guess this is not the greatest example, but let's just look at the code, start from there. So we have the same class hierarchy. We have our virtual destructor, and we have our virtual speak function. We're going to add some functionality now. We're going to make a dance function for our barnyard animals. The problem being, I don't really know how a barnyard animal should dance, right? Because animal is just too general. I don't know. You could say the same thing about speak, I guess. So I'm going to say, well, this is a virtual function dance, but in the animal base class, there's no implementation. I don't know how to make an animal dance. Cats know how to dance, and like birds know how to dance, and chickens know how to dance, but animals, that's just too general. I don't know what I should be doing here. And you'll notice that as soon as I put that in, I started to get some errors. And the error is, well, I get errors all over the place. So object of an abstract class animal is not allowed. All right, well, that makes sense, right? I just put an abstract function in my class, which means that, you know, if I could make an animal and then I called dance on it, well, then it would just, my program would crash, essentially, because this, you know, this is a null pointer. So the compiler says, well, you can't make an animal now, because any animal you make must be able to dance, and your base class of animal cannot. Okay, so you're not allowed to make it. But what's more than that is I can no longer make a bird either, right? So a bird is a descendant of an animal, and I inherited that dance function, but it's still a pure virtual function. I haven't done anything. I haven't provided an implementation for it yet. So that means my bird is also an abstract class, and my chicken is also an abstract class, and my cat is an abstract class. So everything's an abstract class now because they all inherit this dance function. Okay, so let's fix that. I am going to, what is it? Is it called the bird dance? Is there a bird dance? I think so. Okay. So I've made an implementation to this dance function, and well, you can see down here, my bird and my chicken, the compiler is no longer complaining that I'm making them, right? So now I'm allowed to make bird and chicken. These are concrete classes now, because I provided an implementation for that dance function. My cat still can't dance, right? It's still just the same as an animal. It doesn't know how to do it. So let's say, here's my cat. I don't know how cats dance. They run up a tree or something. Okay. And now, so now my cat can dance. My chicken can dance, but it only dances like a bird. I want, specifically, I want the chicken to be able to do the chicken dance or something. Which I'm sure probably exists. Okay, so now everything has its own dance function except for the base class of animal, which means that, Al, the animal here, well, it doesn't make sense to make an animal, right? And really, if you think about it, what does it mean if I make an animal? Like, this gives me not enough information to be able to do something with. A bird, a chicken, a cat, I kind of know what I should be doing. But an animal doesn't make sense anymore. So we can't make an animal. It's too abstract. And all right, so we have a barnyard harmony, and then we can have a barnyard dance. Dance. Okay. I think I'm in the right place here. Make sure. All right, so a bunch of animals were made. We had a barnyard harmony, a bird, a chicken, and a cat, and then a barnyard dance. A bird, a chicken, and a cat, each doing their dance. Of course, then they're all destroyed. But yeah. So that is our abstract class. And our abstract class is a class with an abstract function or a pure virtual function. And although we do not have it separated into implementation and header, if this was separated and there was an animal.cc, then I would not put an implementation in there. Okay, I just leave it blank. I would put, if speak was there, I would put it in. In this case, it doesn't even really make sense to have a speak function. I can get rid of that. So now this is just a virtual base class, abstract base class. And so in my animal.cc, I might have my constructor and my destructor, but I would not have these. That's all. Just leave it blank. All right. Questions? You don't. It's just a nice thing for your fellow programmers to like give them information without having to dive all the way to the, right? It's just a convention. So that, yeah, when I look at it, I understand that, well, either this is a virtual class, or maybe I should check the parent class as well, or check the documentation, right? It's just a helpful hint, I guess. Yeah. Other questions? Okay. Right. So this sets us up. So now we have, we have two virtual functions, and we have, we have a little algorithm here. Very simple, nothing too complicated. I go over all my animals, I loop over them all, and they speak, and I loop over them all, and they dance. And the specifics of these are implemented in the derived classes, which means now if I want to add functionality to my, well, in this case, to my barnyard, right? I can do that by just adding a new class, a new derived class, right? Instead of having to change my general algorithm, well, this will never change except for maybe the initialization step. Like maybe I'll add I'm going to add a pig here, but my algorithm itself doesn't have to change. It's general enough that it's going to cover all the cases, and then the specifics will just be in these function implementations in my class. So I can take this cat. And this becomes a pig. And the pig says oink. And for the dance, it rolls in the mud. Okay, so just like that, I've added, my barnyard is now dynamic. I can add new animals to it. I don't have to change the original code except for, I'm going to do one thing here. I'm going to say big star Wilbur. And then I'm going to push Wilbur onto the vector, right? And those are the only changes I have to make. I just add it to the initialization step. And now my barnyard is a little more well-rounded. Now we have a pig that says oink, bud, and yeah, so that's sort of the power of polymorphism is that I write general algorithms now, and I handle all of the additional complexity of what animal does what. I just handle that in the class functions itself. All right, questions? Okay. Right, so yeah, no implementation in the source file, and any class that has at least one pure virtual function is an abstract class, whether it inherits it or whether it makes it itself. If I have a derived class, it must override this function, or else it also becomes abstract, which we saw. Okay, so here's just a little example where, well, let's take a look at it, and then so I overloaded the assignment operator, which we haven't done that yet, but we're going to get to it. But I have essentially something similar. I have a base class, but now it speaks. And I have a bird that inherits from animal, and a chicken that inherits from bird, and a cat that inherits from animal. And I put them all in a vector. And then I do the barnyard harmony with pointers. So nothing that we haven't done already, but so yeah. Now we have an animal again. Yeah, barnyard harmony. Great. So what did I do here? Well, these are all dynamically allocated, and I use pointers to store the memory address, and then I push those pointers onto a vector that contains animal pointers. So now I'm going to try something similar. I'm going to make a vector of animal objects. All right. So we're, as we go, we will increasingly talk about the vector class because it is sort of central to a lot of C++ code. And then I'm going to push these objects onto my vector. Right, so I made animal owl, a bird Tweety, a little red hen, but these are like statically allocated. They're on the stack now. And the handle is different. It's no longer a pointer. It's just the object itself. And I'm going to push them onto the stack, or sorry, the vector. And then I'm going to do a little barnyard harmony with objects, and syntactically different. So what do we expect to happen here with this barnyard? Right. So just to remind you, the first barnyard harmony, we have dynamic binding. So birds say tweet, chickens say cluck cluck, animals say whatever, the cat says meow. What do I expect to see here? So the question is, what am I going to get dynamic binding? Or what exactly did I do here? Like what actually just happened? And we can substitute, it doesn't have to be a vector, it can be, we could have used an array. An array that contains animal objects. So what happens if I copy a chicken into an array full of animal objects? All right, well, let's run the code and see what happens here. Oh, a lot of stuff happens. Well, so we have the copy constructor. A lot of copies are being made. All right, so I guess we should talk about that. But before we talk about that, let's look at this barnyard harmony. And everything just talks like an animal. All right, so just something to, I mean, it's just a misstep. If you don't quite understand what's happening, and that's, of course, very common in C++, it's hard to know everything. But especially in the beginning, you might think that, oh, I can push a bird, a chicken, and a cat onto my vector of animals, and I get dynamic binding. I get polymorphism, but that's not the case. Because this vector of animals has in the background, it has an array of animal objects. Right, that looks maybe something like this. Let's say there's 3 things in it. But they are animals, right? In particular, they are not pointers to animals, and they are not chickens, and they are not birds. They cannot hold any information that I would put in a bird. They can only hold information that I would put in an animal. So then I come along and I make a bird object, and I push it onto the vector, and it makes a copy. And what does it make a copy of? Well, this bird has an animal part, right, inside. And that animal part gets copied onto the vector or the array or whatever. Right? So if I have a vector of objects, it's a vector of whatever type of object that is. There's no such thing as, well, you could use polymorphism if they were, say, well, no, you can't really use polymorphism, right? If it's a vector of objects or an array of objects or some data structure of objects, then it's just objects. So this bird gets converted into an animal. My chicken also gets converted into an animal. It still has the same name and everything that it had, right? Because a chicken is part animal. So I can copy the animal part. But I lose the chicken information and then cat. All right. Questions? All right. I mean, yeah, technically up here, I do the same thing, but I'm making copies of pointers instead of copies of the animal objects. That's why like a layer of indirection is your best friend as a computer scientist because it solves a lot of problems. Right, exactly. So I don't think we have any extra information in these things. But let's say that my bird, I can put int number of eggs. So I have an extra attribute in my bird. Well, when it gets copied into the animal vector, this number does not get copied, right? Because it's a part of a bird. animals don't have numbers of eggs. So yes, that's correct. Other questions? Okay. And yeah, oh, the other thing, I guess, we made a bunch of copies. So we'll talk a little bit about what a vector does because well, let's talk about it here and we'll talk about it again later. So vectors are, you've made some array-backed lists at this point. So you sort of know what's going on, but a vector is like that, except different. And what's different is that it starts out with an array of size, well, technically size 0. It starts out with no array, but as soon as I add something to it, it adds this array, right? So I have a vector class. And if I add an animal, well, it allocates an array of size 1. It copies that animal into this array. And then I have a vector that contains this animal. When I add the second animal, well, it looks at the backing array and says, oh, there's not enough room here. So I have to make a bigger backing array. And so it does. It goes off and it asks the operating system to malloc it off a new array or uses new or whatever. And then it copies this animal over to the first location, and animal number 2 gets copied into the second location. So yeah, let's call these A1 and A2. And again, it's fine. Now it's holding 2 animals, but right, I made a copy. The first time I copied A1 in, I made a copy. And then when I had to expand the vector, when I had to make a new backing array, I made another copy of A1 and also a copy of A2, right? So that's 3 times I've invoked a copy constructor on animal. And, you can see that here. So the constructors are initially here, or sorry, here. And then you can see a bunch of copies being made. Not as many as you would think. Like the compiler is a little bit clever, it's doing some optimization. But in general, every time I run out of room in my vector, what happens is that if I tried to add A3 here, well, it would say, well, I'm out of room again, so I'm going to double the size of the backing array. So now I will have 4 things. I'll copy A1 into the first, A2 into the second, and A3 into the third, and then I'll have room for one more if somebody adds another one. And then, after it copies everything over, of course, it destroys this old array. And then the destructors are called. So if you have a vector of objects and you're adding, if you're adding them one by one to that vector, you're doing a lot of work behind the scenes, right? You're copying objects, you're deleting objects, you're allocating memory. So vectors of objects are not generally very efficient. If you know exactly what size it's going to be, then there's steps you can take to just pre-allocate and then just use that same size throughout the life cycle. But in general, it's not a good idea, at least if you're concerned about performance or copies being made, to use a vector of objects. All right, questions? Okay. Oops. All right, so that's polymorphism. Polymorphism is, it's hiding a bunch of details from the compiler and even from the client algorithm, right? Those details are contained in the derived classes, and that's nice because I can write this nice general algorithm. And then when I want to add functions, I just add a new class that has a new type and maybe does something a little bit differently, right? But on the other side of the spectrum, we have this runtime type information, right? So you can do things in C++, you can ask for the type. So technically I have a vector of animals. I don't know what they are at runtime. I just, it makes the function call, it makes the correct function call. But as the client class, I can't really check if that's a cat or a bird or, well, actually I can. I can use this runtime type information. Not a great idea, generally speaking, and we'll see why. But on the other hand, Java does it, right? If you ever do GUIs in Java, then you get, what do you get, an action event? And if somebody clicks a button or something, you get an action event, and then you check to see if it's a button, the thing that I don't know, there's some field that contains the thing that got pressed or the text area that got clicked on or whatever, and then you cast it to a button, and then you can do some button stuff to it or whatever. You can make it look like it was pressed, right? So Java actually does this sort of thing. It checks the underlying type at runtime. Generally speaking, that's a bad idea, but of course, everything has its place, I suppose. Nothing's a bad idea all the time. But yeah, we can do this in C++. We will look at some of the good and bad, I suppose. So again, we have the same class hierarchy we've been looking at. We have an animal, bird, chicken, cat. They all sing and dance. Yeah, so I have the barnyard harmony and the barnyard dance and then the barnyard slaughter. So let's just run that to make sure everything's working. So great. Barnyard harmony, barnyard dance, barnyard slaughter. Sweet. Okay, so what I want to do now is, well, I want to introduce some new behavior, but I don't really want to use polymorphism because whatever, maybe I'm lazy or maybe it just doesn't fit in this context. So what I'm going to do is a dynamic cast, or I'm going to try and do a dynamic cast. So there's a function, and which library is it in? IOStream, I guess. Well, actually, now that I'm thinking about it, I'm not sure, but I want to see if this is a cat. So as the barnyard dance progresses, I have some special cat behavior that I want to implement. So I want to check to see if this is a cat using a dynamic cast. Right? Dynamic cast is templated, which we've talked about a little bit. Vector is also templated, so I have to give it a type, and the type is cat pointer, right? I want to see if this animal pointer here is actually a cat underneath. So I'm going to cast it to a cat pointer. I'm going to pass in barnyard. Oops. Right. I'm going to pass in this animal pointer, and I'm going to try and cast it to a cat pointer. And if it's a cat underneath, this is going to work. And if it's not a cat, it's going to be 0. It's going to be null. Okay, so now I can say, well, if cat not equal to 0, well, then supposedly I have a cat here. So I'm going to say, well, the cat, does this cat have a name? Now, is it private? Inaccessible. Okay. Let's make it public just for this example. Okay, the cat runs up a tree. Okay, so in my barnyard dance, the cat should dance, and then if it's a cat, it should run up the tree, and nothing else in my barnyard should be affected. Okay, so the cat Lily pounces and then runs up a tree, and nothing else ran up the tree because nothing else was a cat. So I successfully casted this to a cat pointer. So yeah, I did runtime type information. I checked the underlying type at runtime, and because it was a cat, I did this thing. All right. Questions? Okay. Now, is this a good idea? Right. So, well, this is not polymorphism, and I guess to answer that, sometimes, yeah, Java does it. But let's see what can go wrong in this case. Let's say now, where's my cat? Let's say now I make a subclass of cat, right? So I have a cat. This cat never falls. I don't know. What is it? Brave cat. It never gets scared and runs up a tree. Let's say. Other than that, It behaves mostly like a cat. Right. So there I have a new class, and it says meow pounces bravely, I guess. I have a new cat. It has a little bit of new behavior, and so now I want to add it to my barnyard. I don't know what's the Lion-O. Lion-O is brave. Okay. So I've added this cat, and now I'm going to push it onto my vector. And so now it's part of the barnyard, and it's going to do the dance. It's going to do the harmony. But the problem is this is a cat that never gets scared and runs up a tree. But in this case, I use dynamic casting, it ran up the tree, right? Because a brave cat is a cat. It inherits from cat. So when I ask if I can dynamically cast this animal pointer into a cat pointer, it looks at the underlying type and says, yeah, it's a cat. So sure, go ahead. So now, because I've mixed dynamic casting and traditional polymorphism, I have some weird situation now where I have some behavior that's supposed to apply only to cats, but now it also do all these subclasses of cats. And I don't necessarily want that, right? So it can be kind of brittle to future changes, right? If I do dynamic casting and then I make a subclass, I better be sure that the subclass is going to want to do this, whatever I implemented. Okay, that being said, it's not that you should never use this. It's used very successfully in Java, but do be careful. So yeah, questions? All right. There's other runtime type information you can get. Geez, not all compilers enable this by default. I forget, I did look it up at one time. You can get, you can ask for the actual class name, like the string of the class. So you can like print out, this is a class type, whatever. There's some other stuff, but the main one you would be interested in is that dynamic casting, right? That's a traditional cast. But I think it is, it's type safe, right? Traditionally, when you cast in C, you better be sure that you're casting, right? If you're not casting the proper type, you can get some undefined behavior. But here with dynamic casting, we're protected against that. Okay. Yeah. What if you want to check the type? There are ways to do that. I would have to look them up. I don't remember off the top of my head. Again, you can ask for the string, and then you can check to see if the string matches what you expect. I guess that would work. But yeah, you should, I haven't used this very much. There are some other information you can get, but I would have to look it up. So yeah. All right. So that brings us to, well, polymorphism. So we're going to do a little bit of a larger example of polymorphism. We're going to take sort of an existing program, and we're going to refactor it. And we're going to try and fix a bunch of problems with it, right? So there's bad design in this program, and that's not a bad thing, because what happens is I sat down and I had a problem to solve, and I solved it. Right? I wanted to make a game where a couple of people fight to the death or whatever. And so I did that. I just solved the problem at hand, but in doing so, I introduced a bunch of stuff that is sort of ugly and maybe not resistant to change. In particular, maybe I want to add new characters to this battle. So right now I have hard-coded a hero and an orc, right? And they are part of this battle. And one of the things that I noticed about my hero and my orc is they actually have a lot of things in common, right? So they have a position, they have a health, they have an avatar, which is a string. And so both of them have that. They also duplicate a lot of functions. Oops. Right, so this get hit function, this is dead, update, print. Collide is the only one that doesn't appear in both, right? So the orc also implements get hit, is dead, right? So this is like, it's called a bad code smell, or, I mean, it's not even necessarily that it's a bad thing, it's just something that you might encounter. When you get to a certain point in writing a program, you might notice, hey, like these classes have a lot in common. Why don't I extract a superclass? And in fact, that's so common that I think your IDE will do it automatically, although I've never actually tried to do it, but you can identify things that it has in common and extract a superclass, and it will do all this refactoring for you, right? So what we're going to do, among other problems, but in particular this problem, we want to take this, these two classes and extract a superclass. We're going to refactor it, which means that the program is going to function exactly the same when I'm done. I'm just redesigning it. Okay, so I'm redesigning it so that I can add new classes easily. All right, so if I look at, I will just draw a very simple UML diagram, but there's a battle class that is sort of the control class, and this battle class contains a hero class and an orc class. And it also has a board, which is what my battle gets displayed on. And is that it? Oh yeah, it also has a swing. A swing class, which is part of the hero and the orc class. Okay, so they have a swing, which is sort of the weapon. I don't know. The naming I used is not that great. But it's sort of very simple. Battle controls everything. The board is like what we view the battle on. The hero and the orc are like the model, right? So they contain the information that we need to decide who's winning and things like that. So yeah, our program is going to look something like that. And what we want to change it to is this. We want to add a character class. And all of those functions that they had in common should go up here, like is dead, get hit, as well as all the member variables. And then this will be the superclass of these two. And well, they have swing in common as well, so that will be that will belong to the character superclass. And then what I want to have down here is you know, hero and an orc, and they can implement some specialized behavior if they want. But what they're really going to be doing is overriding things like the update function. And so if I want to add a class, basically, I have a lot of the work already done for me, right? All of the work is already in the character superclass, and I just have to, you know, have to rewrite the update and maybe the print, and voila, I have a new class that I can introduce to my game. Okay, so that's the idea behind this next example. What's up to date, but I doubt it will run. Okay, so yeah, don't get intimidated by the amazing graphics. But here what we have is, this is my orc, right? So the orc moves slow, and it has short weapons, but does a lot of damage when it hits. The hero here, you can see the hero jumps all over the place. Has a longer sword that randomly swings either behind him or in front of him. And he moves very fast, so he randomly jumps across the board as well, right? So the orc is just sort of plodding along, and the hero is jumping all over the place and swinging wildly. And when they hit each other, they take damage. So in this case, the orc takes 5 damage. And you can see they lit up red. And then down here, you can see, the hero got stabbed by the orc and took 7 damage. And then a little further on, the orc gets stabbed. And oh, the hero wins this one. Sort of unusual. If we do it again, we can see some specialized behavior. So here they have collided. So they're both on the same location. So we get the red X. And when that happens, the orc is a lot tougher than the hero. So the hero takes a lot more damage. But yeah, so that is the game. Very, very simple. And the board is, of course, just this is just an array of characters. Shocking, I know. I didn't use any, but yeah. So this is a game. We want to be able to add new characters. And if we look, well, my battle class contains a hero, contains an orc, and some basic functionality like, you know, is the battle over, an update, and a print result. So very, very simple. I am going to, in my main function, make a new battle. While the battle is not over, I update, and then I print result. So we can see this is nice and simple. You know, here we're being wise and we're hiding implementation details, but in the, yeah, I had some unit tests here too. We can just ignore these. But yeah, where it is a little more complicated, where we kind of want to clean things up, is in my battle class. So battle, I have is over update print result. And the update is where you can see that I'm not really using polymorphism. I am, you know, acting on the orc and the hero directly. So I start by resetting the board. I update the hero and the orc. I draw the weapons onto the board first, because I want the heroes to be drawn on top of the weapons if they happen to be in the same location. Then I draw the heroes onto the board, and then I see if they hit each other, right? And then after I see if they hit each other, I see if they've collided, right? And then the orc gets that special attack. And then I print out the board, right? After I've done all the updates, I've set things red where they have to be red, I've drawn things where they have to be drawn. Then I show the board, and then I show the stats of the hero and the orc. And that continues until we're done, at which point, where is it? Yeah. At which point, when the battle is over, we print the result. If they're both dead, we say we're both dead. Otherwise, we print which one is victorious. Okay. And yes, hero, this is, you know, we have a position, we have a health avatar and a swing, and the orc, well, we have those exact same things. And in fact, we have all of these things in common, right? So the orc is basically a hero minus one function. A hero is an orc plus one function. Okay, so yeah, we're going to extract a superclass. Questions? All right. Yeah. Yeah, that's there's a special, I think it might be a Unicode character. Let's see. So I flag it. Yeah, it's this special, I don't know. It's a Unicode character, and it doesn't, so I did this in curses as well, right? I'll show you guys that in a minute, but I tried to do this in curses and it didn't work. So it doesn't work everywhere, but it happens to work here. Yeah, and you can change the colors, and you can do some other stuff. So this is the red color, and this is back to the original color. Yeah. Other questions? All right. Okay, yeah, let's make a new, so yeah, the goal is I'm going to extract a superclass, and after I abstract the superclass, the game is going to function exactly the same way as before. It's just going to be easier to modify. I want to add this character dot H. That's going to be the superclass of my hero and my orc. And I'm just going to basically, well, let's just grab everything out of here. And I'm going to copy that into character.h. I'm going to remember to change my header guards, right? If I don't, this will cause me headaches later as I try to figure out why it won't compile. But okay, and then I will change class name. All right, so collide is not in common between hero and orc. It is only in the hero class, so I'm not going to include that. Everything else is fine though. And in fact, if I look at the implementations, well, this get position, get swing, get avatar, these are just getters. And if I look in the orc class, they are just getters. So we have exactly the same implementation of both of these classes. So I'm going to include the implementation of these in my character.cc. So here, character.h. And then I'm going to, well, I'm just going to grab all this. Even the get hit is the same between the two, is dead also the same. So I'm going to grab all of these and put them in my character class. And then change all this to character. And voila, I have an implementation of all of those things. I just stole them from the hero class. I still don't have an update in a print, but I'm a character. I really don't know how to update myself, right? So if I look at the hero code for update, well, if we're dead, we do nothing. Otherwise, we choose a random position across the board, and then we choose a random direction to swing the sword. And then we update the swing, which I'm kind of using, it's a class, but I'm kind of using it like a struct, right? I just need it to hold a bunch of information that's related. Right? Again, I used bad design. I just solved the problem. We'll fix some of this stuff as we move forward. But this is what my sword looks like. If I swing to the left, I draw it like this. If I swing to the right, I draw it like this. It does 5 damage, and this is the area that's affected. And if I look at my orc, well, the update looks a little different. I randomly choose a direction and then move in that direction as long as I'm not walking off the end of the board. And then I always swing in both directions, right? So the updates are a little bit different. So I don't want to make any assumptions in my character base class. So I'm going to set this equal to 0, but of course I have to make that virtual. So this is now an abstract base class. And my print, maybe I could get away with using the same print, but I'm going to make that virtual as well. So how these characters print out and how they update, that's up to them. Everything else I can handle in my character class. All right. Yeah, question so far? All right, final step, I'm going to turn my hero into a character. So these I no longer need. These I'm going to add the virtual keyword just to be nice to my fellow developers. I no longer need these, but there is one more thing I should probably do. So now my hero is getting very, very simple at this point. I'm going to make these protected though, so I don't have to change too much code. Right? I want to inherit these. I want to have access to them in my hero subclass. And then I'm going to say publicly inherit from the character class. And of course, the compiler has no idea what I'm talking about, so I'm going to provide the definition. Oops. And voila. Right, so I've reduced this subclass into like the minimum difference between characters. A lot of the character stuff is the same. So I just naturally want to extract a superclass. And now my hero consists of, well, how should a hero update? Well, if I look over here, it updates like this. And how should a hero print? Well, he prints like this. And what happens when a hero collides? Well, he loses 10 health. This since these are protected, these are from the base class of character, but I have access to them here. So now I can just sort of change the minimum amount of code. Okay. So what have I done so far? Well, my orc is still, my orc is not a subclass of character, but my hero is. Right, so, and it should still work exactly the same, right? I refactored, I tried not to change any of the implementation. So once I compile it, it should run the exact same way. And if so, then I'll change my orc. Other thing, of course, is it's not going to compile because I don't have a character class that compiled here. So let's add that in. Okay. And that should be okay. Let's see. Nope. Hero.get position, yeah. So what happened here is that the makefile is either it's malfunctioning or I just didn't set up the dependencies correctly. What does it like? Oh, yes. Oh, there is one more problem. Undefined reference to this character constructor. So if I look here, I included a character constructor, but I don't have a character constructor here. And in fact, I don't really want one. I don't need it in this case. Right, so I have a hero constructor, that's enough. The hero has access to these, so the hero can initialize them however he likes. And voila. So it compiled. And wow, the hero really took a beating that time. But he was moving around and swinging his sword the same as he always does. So yeah, I refactored, I changed the design of my code. I did not change the functionality, which means that if I had a bunch of unit tests, right, which we saw in the beginning, which I commented out, I didn't bother running them, but if I did, and then I refactor, I can go back and run those same unit tests, right? And they should all still work. Or maybe not the unit tests per se, but there is a test suite. If I have a test suite, I should be able to still run it. Okay, let's get let's do the orc now. I don't need any of that. I don't need any of this. I need a character. And these should be virtual. They don't have to be, but I'm going to be nice. And then in my implementation, I'm going to get rid of this. And I have a bunch of errors because the last thing that I forgot to do is to make it a subclass. Okay, good. Perfect. Okay, great. I refactored my code. It works perfectly. Question so far? A bit of a bigger example. We'll come back to it again in the future. I'm going to do a little bit more here. I'm going to generalize my algorithm now so that I can add a third class called a wizard. That maybe will take us to the end of class. So yeah, that's great. But now I want to, well, the whole point of this was so that I can add new characters. And I can add a wizard class and just put in an update and print function, and I'm good to go. But what I don't really have is an algorithm that will work because these guys are hard-coded in here. All right, so instead of a hero and an orc, I'm going to do a vector of character pointers. And oh yeah, so it gets the character through my hero. So yeah, I expected it not to recognize this, but it does. And so now I'm going to adjust my code so that it runs on this vector, and then I get some arbitrary number of characters. The first thing I want to do is push back a new hero. Okay, and now is the battle over? Well, the battle's over when there's one person left standing or nobody left standing. So int dead equals 0. And then I will say for I'm going to use a for each loop. Right, I'm just going to take each character pointer and say if is dead, then dead plus plus. Actually, it might be easier to do alive. It's fine. Okay, so I'm counting the number of dead characters, and then if the dead is greater than or equal to, I think. And I will return true. Otherwise, return false. All right, that's not the best way to write it, but that gets the job done. So I loop over everybody. I count how many are dead. If there's one person left standing or 0 people left standing, then the battle is over. So then I'm going to do the same thing over here. I'm going to use a for each loop again. What about return dead? Yeah, if I did it a little differently, right? So what is it? 0 would correspond to, does C++ do an automatic conversion there? I could do something like that. Yeah. Return. Yes, I could easily do something differently here. That would be a lot more compact. You're right. I'm just doing something that is obviously correct to me. And yeah, if I had a little more time, if I was taking my time with this, I would be more careful about it. But all right. The hero and the orc move. Well, I'm just going to say C update. Right, so now I no longer have to do this individually. I can add, and if I add more characters, this is still going to work. This part, oh, good grief, I have my work cut out for me here. I mean, if dead is more than 0, then it's true. I'm going to, so if there's 3 people fighting, I'll go till one person is left standing. That was the idea. And yes, it's true if at least one person. Yeah, I need either everybody dead or everybody but one person dead. This one, board.set character. Right, so I'm taking the hero's swing. Right, so again, I write everybody's weapons on the board first, and then I'm going to write, oops, that's not what I wanted. Let's do this. C. And it's worth noting how ugly this code is. Right? Again, I just did what I needed to do to get it done, but you can see here, like I'm saying, like, we'll take the hero. get the swing class and then grab the weapon from that. Like this is long and very hard to follow and kind of ugly, right? And what I'm doing here with my set character is I'm exposing a lot of implementation details. I'm saying, well, I need a string and I need a position. Kind of what I probably should be doing is making a game object and just passing that in. And then inside this set character function, I can decide how to use that game object, right? So this is really, really ugly code. But again, got it working. That was my goal, so I don't really care that it's too ugly. And then, yeah, this part, I believe I have something that's sort of done. Rather than go through every single thing, this, I could also put in a for loop, but now it's going to be a double for loop, right? It's going to be something like, well, I'm going to loop over all the characters once. Actually, let's go. I think I have a working version. Yeah. So yeah, battle is over. I update, I set their weapons, I set their characters. Here is where everybody tries to hit everybody else. So I set up a double for loop and I say that, well, if the two pointers are equal, obviously I don't want to hit myself. So I'm just going to continue here. Otherwise, I'm going to see if the weapon from character number 2 hits character number 1. And if so, I'm going to set that position to red. What did I do? Get hit is undefined. Oh, I was going to say, it was just working a second ago. But I managed to drag a character around. On this collide logic, I had to get rid of because I no longer have access to the hero. Right? I could do a dynamic cast here, I suppose. Right? I could loop over everybody and say, well, are these two people colliding, and is one of them a hero? That's actually a good idea. I should have done that, but I'm not going to bother with that. We'll just, or maybe I'll come back to it in a second. This part here, actually, I do check to see if they're colliding. Yeah, so I can do it. I check to see if they're colliding, and I set that to X. Let's do a dynamic cast. Why not? Well, we'll just check C1. Maybe I should check. I think just checking C1 is sufficient. And then I'll say if hero is not equal to 0, then hero collide. There, look at that. We implemented, so it did come in handy, dynamic casting, right? I had my one hero has that special collide function, and I can access it using a dynamic cast. I print out all the characters once I print out the board with all their stats, and then the results, again, slightly different. I see if anybody's left alive, right? I go through, and if somebody's left alive, I know either one person is alive or nobody's alive. So if it's null pointer, then everyone is dead. Otherwise, I print the last one standing, they are victorious. And I add a wizard here. I did add a wizard. All right, so that's, I changed all of those hard-coded hero do this and orc do that into for loops, working, all of this is using polymorphism on these character classes. There's still some ugly stuff here that we can fix, but yeah, now my algorithm is very general. I can add as many characters as I like, and they should be able to fight to their heart's content. Questions? Okay, so let's see what we have to do in order to make a new class. Yeah, so I called it something else here, didn't I? Chars. Okay, perfect. Before I do that, I'm just going to show you. We've got 10 minutes left. All right, so I do have a curses version. So P7. And that is kind of interesting because what I found is that I really started bumping into my bad design when I tried to implement it into curses in now two dimensions instead of just one dimension, right? So technically, this is fight takes place along this single dimension. But if now I have an arena that is square or rectangle, now it's a two-dimensional game. And I really started to get into like how bad my design was. So in this version, uh, you can see the thing I was talking about earlier, where I should make a game object, I did that because I have information now that I need. And even this is kind of terrible, but you know, it's better than it was. Right, I need to know which way they're pointing, and well, let's look at the game, I guess. And then, yeah, doesn't like my formatting there. I'll come back to that. It's just a warning note, it does work. But yeah, so there's my two-dimensional version. Now there's so much space now, though. So the orc still walks one space at a time, and the hero still jumps all over the place, but they hardly ever hit each other. You can see here the hero took a hit at some point. I thought it would be fun to do it in two dimensions, but it turns out it was really impractical. It would be fun, but it's not like something, you know, that you could work through easily in a class. um, but yeah, all the extra information, like the hero's got to be able to swing up or down, and then that involves different drawing processes, right? Because now I have to draw vertically or horizontally, and so yeah, all of the bad design things that I had ignored earlier came back to bite me here, and this will just go on forever, I guess. But all right, but it was fun. Um, all right, so let's make a new wizard class. Here. Okay, so what do I want to do to make a wizard class? I want to do the least amount of work possible. And so I'm just going to make wizard.h. Now this is largely going to be the same as hero.h, so I'm going to take everything from there. I'm going to make sure to change this. And this, oops. All right, wizards don't collide. That's fine. Everything else, great. Let's add a wizard.cc. And what should I put in it? Well, rather than, well, basically I have to do update and print. The print should be very straightforward. So what do I want my wizard to do? I want my wizard to, he's going to walk very slowly like an orc, but he's going to throw a magic fireball that randomly appears somewhere on the board. So let's change this to wizard. If they're dead, I return. Oh, yes. And okay. So yeah, I'm going to steal the orc update. So the orc, this is the orc moving slowly. I'm going to put that in my wizard class. And this is where the fireball will end up. And fireball will look something like this. It's going to be a bunch of fire. The left-hand side will be the fireball position. And the right-hand side will be fireball +4. Right, so this is just the area of effect. This is the left-hand side and the right-hand side, and if a character is somewhere in this range, they take the 5 damage, but it's a fireball. Let's make that 10 damage. All right, so that's it. I just made a new class called a wizard. I stole a little bit of code, introduced a little bit of, it's old behavior, but I repurposed it. And now I should, with a little luck, be able to push this new wizard onto my battle class. Wait, am I in the right spot? Regardless, it should be fine. Oh, well, I do have one problem. Undefined reference to wizard, yes. I have a constructor, which I don't have an implementation for. So yes, sorry, wizard. And if I look at, say, orc, I want to set these things. Health is, well, the wizard's pretty weak. The health is 10. The starting position, we'll say, is also 10. The avatar is a wizard. It's a W. Okay, let's try that. Am I like just in 2 different places here? That's possible. Wizard, wizard. All right. Can anybody see what I'm missing here? It says it undefined reference to my very good. Yes. I did not add wizard to the make file. Thank you. So yeah, that's why I couldn't find the implementation, because there did not get compiled. Wizard print. Oh, I didn't print. Jeez. All right. Perfect. Okay. So I have my 3 characters fighting it out. The wizard is throwing a fireball around. You can see it here. I almost hit the orc there. Oh, I hit the hero there for 10 points. That's nice. Right. So yeah, so it's pretty simple now, aside from tracking down those few bugs, but to make a new character class, just change a few implementation details and add it to my game. All right, so I've improved using polymorphism and also refactoring, right? So again, when you start making an application, what I look for, or what I do at least, is I try to make it correct first, right? I try to use good design, but I'm flexible in the beginning. It has to work. It's useless if it doesn't work. And then after that, you can improve the design. You notice, like, and especially when you try and make changes, that's when you're going to bump into these problems and say, like, you know what? If I did this instead, all of this is going to be easier. But yeah, so that's one question here. This level of complexity. Yeah, I mean, it depends on what you mean by this. I expect that it will have this level of complexity, yes. Right. Your assignments, because there's 5 assignments, I usually do 4 and then but with 5, I'm sort of trying to streamline the lessons in each assignment a little bit. So it's like, it should be this level of complexity, but again, we're going to be focusing in on a few details rather than trying to implement everything at once. But yeah, questions? No? All right. So that's it for today. Or what are we? We're the Friday class, eh? So we'll see you guys on Friday.